this workshop that's coming up is particularly interesting for those of you who are maybe coming from a more Ethereum or sort of another type of blockchain space that is focused more on smart contracts, right? So with Substrate, you might be wondering, how can we have the same kind of capabilities that smart contract chains allow us? And essentially, we've been talking a lot about runtime logic, right? Where a Substrate blockchain really is the putting together of palettes that enable specific business logic for your blockchain. But with smart contracts, we can do other very interesting things too. And it's also a very great way for people who are used to writing smart contracts to get engaged with building with Substrate. So next up, we have Bonan Yuan, who is a developer at Patract Labs. Patract Labs is developing an extensive amount of tools for smart contract developers that are building with Substrate. And I'm super excited. Guys, you need to buckle in, because this is a lot of really, really, really cool stuff. I encourage you, while we're seeing the workshop, look at resources, go on Patract's website and kind of explore the docs as Bonan is going through them, and ask questions, right? As usual, just kind of immerse yourselves into the chat and put your questions in the Q&A box. Without further ado, I want to give the stage to Bonan. Take it away, Bonan.
Hi, thank you so much for the introduction. So I'm Bonan Yuan, aka CryptoJedi. So I'm representing Patract Labs for a workshop concentrating on smart contracts for Wasm base. So Patract Labs is founded with a vision to provide full-stack support for smart contract developments based on Substrate. We understand Substrate is a fast-growing ecosystem for a variety of different blockchains. They're all carrying different purposes, and we are seeing all kinds of Substrate blockchains projects booming and emerging. However, we think smart contracts will also play a very important role in the Substrate ecosystems by overseeing the exponentially booming projects in other blockchain projects, such as Solana, Ethereum, and US. Although many smart contracts projects are very small, but they have brought tremendous value to the blockchain ecosystem. For example, the DeFi projects like Uniswap on Ethereum, Serum on Solana, they are now playing vital roles in the blockchain industry. They have created liquidity and many practical use cases for the blockchains they were built on. However, all those projects, the successful projects, are backboned by the solid developer tools such as Truffle, Etherscan, and Galaxy. So in Patract Labs, we believe by providing mature and secure development tools and services, where benefits the whole Substrate ecosystem by attracting more developers from other blockchains. So we are dedicated into Substrate ecosystem by providing all kinds of tools and products needed for smart contract developments. So we are extremely excited today to be involved in the Sub0 seminar by providing the following products. So bear with me for a while, since we are providing a lot of tools and services. They are all like together, so like you can each product is usually used with another product. So let me introduce them like step by step. So the first product I'm covering today is called Jupiter. Jupiter aims to be an open blockchain network, which provides wide support to all smart contract developments, as long as they are running on Frame contract palette. Jupiter has been alive in the Substrate network for a long time, and any developer is welcome to use it for free. The second one I'm covering is called Ask. Ask is another embedded domain-specific language, or called EDSL, that allows developers to write Wasm Smart Contract in assembly script. We'll cover more details later. Redspot is a contract dev scaffold, which means its goal is to liberate developers from tedious and repeating work and manual work like contract compilation, deployment, and testing. We hope contract developers can finish all their tasks with just one command and in one place, so that they don't have to switch over like compiling, uploading, and all stuff. We hope they can just have all those stuff done in Redspot. Metis is very similar to OpenZeppelin. It is a standard contract library. It provides secure and audited implementations of all the commonly used components in Ink. With Metis, developers won't have to write their own code like for existing implementations, or copy and paste them over and over again. The next one is called Europa. Europa is the contract sandbox environment designed specifically for Substrate smart contracts. It allows developers to inspect smart contract logs and execution details. It also removes some unnecessary components from Substrate, but reveals more details and insights of the contract execution process. Elara is a high availability Substrate API. We have specifically designed the cache system, so it has comparatively very low cost compared to other infrastructures. Parascan is our blockchain explorer. However, it put more focus on inspecting the smart contract logs and executions. Theoretically, any Substrate blockchains can connect to Parascan, and we will provide ad hoc blockchain explorer services. Right now, most of SDKs for Substrate, they are written in JavaScript. However, many projects and services, they need to communicate with Substrate in other languages, such as Go, Java, or Python. So Himalaya is the SDK that provides multi-language support. So this slide, we were talking about the current problems with contract developments. So I'm a technical educator with Patract Labs. So I have developed some contracts using the Substrate, Ink. I would say the overall process isn't that easy. Like from a stand, because I'm not like Substrate background, and I'm more from like Ethereum-based blockchains and smart contracts. So I would say the overall process isn't easy. So in Patract Labs, we are trying to solve all those existing problems by providing the products we have. The first thing is, right now we only have Ink, which is written in Rust. So that means developers can only write a smart contract in Rust. Although Wasm can be compiled from different programming languages. So we are proposing Ask. Ask is embedded EDSL that allows developers to write in assembly script. The second problem we are facing right now is lack of development suites. So oftentimes I have to compile my projects, deploy my projects manually to like Canvas, which is the like default node for smart contract development. So that is very time consuming. So we have Redspot. We will cover more details later. The third problem is lack of standard contract library similar to OpenZeppelin. Developers now have to copy and paste the code. This is very time-consuming and error-prone. So we have Metis. Metis will solve the problems by providing standard implementations in components. The first problem is lack of test sandbox. Unlike in Ethereum, we have Gantry, which is one-click blockchain. You can just download the binary and fire up your personal blockchain in 1 second. But right now, there is no out-of-box contract test sandbox designed specifically for contract developments and debugging. For this problem, we have Europa. Europa will be the one-click blockchain that gives you a very good experience debugging and testing your contracts. So the first product I'm covering here is Ask. Very similar to the macros in Ask. Many of us have played around with Link. However, a great advantage of Wasm is that Wasm allows multi-language compilation. However, right now we only have one language in Rust and in Ink that compiles it. Ink is a very great language. However, it requires developers to be familiar with Rust as a pull requests. Therefore, we created Ask, which is EDSL similar to Ink. With Ask, anyone who has experience with TypeScript or assembly script can easily develop Wasm Smart Contracts. Overall, we're trying to bring the Solidity style development into Substrate to attract more developers from Solidity. First of all, Ask is the EDSL. It is very similar to Ink, as Ink is the EDSL in Rust. It provides, the grammar is same as assembly script. So very similar to the usage of macros in Ink. In Ask, we have decorators. That gives very similar code layout as Ink. So people who have written Ink projects, they can get familiar with Ask very fast. With decorators, it also gives high-level abstraction. Developers can now focus on the contract logics without learning how to interact with host functions and the padded contract. Basically, all the complex stuff are now hiding in the hood and done by Ask in the backend. In Ask, we are providing 4 storage types. They are spread storage map, spread storage array, pack storage map, pack storage array. So basically, when you have lots of data needs to be stored, spread should be used. When you have a small amount of data, but you need access to most of the data, or you need to run statistics on them, it's better to use packed. Another great feature with Ask is it supports interfaces and inheritance. As we all know, Rust doesn't have inheritance, so when we were developing Metis, we were having a hard time since it's going to be a complete different development style. Luckily, we have Ask, so Solidity developers can quickly get used to it, and we will support standard contract libraries very similar to OpenZeppelin. So with simple inheritance, you'll be able to create very complex contracts. So the current development stage of Ask is still at 0.2. We will be publishing a 0.3 in near future. That will be the production code to be used. Redspot is our main role today. Is our main player today. So we'll be covering a lot in our workshop. Redspot is a development environment to compile, deploy, and debug Wasm Smart Contract for substrate chains. Redspot helps developers manage and automate the repeating steps during the process of writing smart contracts and dApps. Redspot is the development environment to compile, deploy, and debug Wasm Smart Contract, very similar to the architecture of Hardhat. Redspot is built upon tasks and plugins. The first great feature of Redspot is it provides templates. Based on different contract standards, Redspot will automatically generate sample contracts, deploy script, test script, and configs with a simple Redspot new command. For example, running npx Redspot new ERC20 will create you a sample ERC20 projects with testing deployment script. It also has npx support, so you don't have to download or set up anything yourself. It also has compile feature. It runs around cargo contract. npx Redspot compile. This command will compile the code and put the code into corresponding directory for development. So with another great feature is called deploy. Using the deploy script, it will upload the contract and instantiate it in blockchain. You just simply run npx Redspot run deploy.ts. A big problem right now with contract development is you have to sometimes you do the integration test yourself. You have to file up the blockchain and play with it to test transfer, all those functions. So with Redspot, you can write a customized test script that tests other functions in your smart contract. It also comes with a very powerful JavaScript console for testing, for integration testing. You can use this console to control the blockchain operations, such as forward to a certain block or revert it. Also, before you write any detailed testing code, you can always play with it in the console. You can understand how Redspot works, getting a sense of how you're going to test your contracts, etc. Redspot also supports plugins because Redspot is built upon plugins. So if you feel like Redspot is not enough for development, you can always write your custom plugins and add it to Redspot. You can add more features, more integration tests with other development tools as well. Also, because substrate, you can always customize your substrate chains by have different types. So with the usage of plugins, you can stay compatible with custom blockchains and extending the types by writing some simple custom plugins. This is an image of how Raster Explorer looks like. Raster also comes with a very powerful Explorer. It is similar to Polka.apps, but with more focus on the smart contract side. It is fully integrated into Redspot configs with no more operations required to connect. So as I mentioned before, to solve the problems with people right now have to copy and paste the code, we have Metis. We call it the Rusty solution for standard contract library. So the current problems when we're developing Ink is we lack of standard libraries. Lack of standard libraries makes the smart contract unsafe. Remember the DAO attack happened in 2016. This DAO attack stolen has stolen 3.6 million ethers due to a bug in smart contract. And this attack enforced hard work for Ethereum mainnet. Therefore, non-standard contract will cause tremendous economic loss and further impacts the future of blockchains, even the consensus. Imagine had the same attack in 2021, people will really question the securities of the blockchains. And but this simply caused by the bugs or non-standardization in smart contract developments. So another problem is developers have to manually copy and paste existing implementations. The source code could be unaudited and unsafe to use. Imagine copying the code from another smart contract project. They may have bugs in their contracts that hasn't been noticed yet. Reckless copying their code will cause tremendous problems in the future. And another thing is very time consuming and error-prone during the copy and paste. You may misunderstand or miss some logics during the copy and paste, and you will waste tons of time to stay updated. If their contracts get updated, like if they update their smart contracts, you have to basically do the same thing, copy and paste their code again. So to permanently solve the problems listed above, we created Metis. It is a standard contract library based on reusable components. But unlike OpenZaplin's inheritance model, Metis is based on components, which means the users don't directly inherit the standard implementations. Instead, Metis provides a set of reusable components for users to assemble. The main reason is because Rust isn't an OOP, inheritance won't be possible in Metis at all. So let's talking about Metis versus OpenZaplin and how they differ. So the first thing is the inheritance is used by OpenZaplins. The pros of OpenZaplin is simplicity. It minimizes the code you need to write. However, it also brings ambiguity. It conceals method definitions. You may have uncertain inheritance trees with multiple inheritance. For example, in OpenZaplin, when you have multiple inheritances from different contracts, you may have a hard time figuring out which parent contract this method is coming from. In Metis, we use composition. The pros of composition is clarity. It improves code readability, audibility of all the functions. People can interact. Also, all the codes are coded in one place. That makes the code auditing very easy. The cons is repetition. So you may sometimes get bored writing the same code over and over again. The architecture used by Metis is called MCCI architecture. It has four parts: data model, components, controller, and interface. Data model is the storage part. It is the contract state mapping, basically we have one data model per component. So if you're writing a complex a smart contract, you're basically putting all those data models together. The second one is component. Components is the implementation. It is reusable and has encapsulation of data and methods. So you don't have to worry about messing all the methods and data out. It is independent. You can always use every component independently. But it also can interact with other components through our controller. So a controller coordinates the components and implements the contract interface. The interface is where the user can interact with the blockchain. It defines the behavior of the contract and to some extent defines the metadata. It basically defines all the immutable and mutable functions. Immutable function basically means the function is to be, it can be queried without transaction, and the mutable functions means you have to use the transaction to make it happen. So this is a graph, shows how basically how users and apps can interact with the MCCI architecture. In the interface side, we have constructor, messages, and events. Those are the basic, if you have written any Ink projects before, you are very familiar with it. So that's basically the architecture. So let's compare how Metis has improved the development experience and more security by comparing Metis and native Ink. So if you look at this image, you will see the left side is Metis and the right side is the native Ink. So users no longer need to declare the variables by themselves. All those declarations are done by Metis macros. And standardize the data structures. So that makes the dApp developments much easier because if it's like ERC20, it always have the same data structure. So this slide shows how Metis differentiates from native Ink in the constructor side. It basically skips the process of variable declarations. You no longer need to manually emit event. Oftentimes you probably forget about the emit event in the functions. So basically Metis does that for you. So this is Metis versus native Ink in event. It basically stays the same. We will improve that in near future by having the macros generate all the events for you. This is Metis versus native Ink in messages. It contains default implementations that ensures the security of balance transfer. So it will take care of all the caveats that may exist in your implementation. For example, when you're doing the transfer, you have to check the remaining balances. So it allows developers to focus more on their core logics. So once you have seen those code above, you might be asking why we can have some code similar to the right side. Like you instantiate ERC20, then you just for every function, just call the function on it. It feels very nature and skips writing all the redundant code. However, instantiation means create an instance of smart contracts on the blockchain. So once you have, so basically, if you call ERC20.new, you basically have a ERC20 in your blockchain already. And calling a method of another instance means calling method from another contract. That ends up with a cross-contract call that will give you the wrong result. So this slide shows you the composition of multiple components. Remember, with Metis, you can always combine different components together to create a very complex contract. This is an example shows a ERC20 possible contract. This is basically the initiation of this contract. We will cover this in workshop in details. Europa is the out-of-box local testnet. It is another implementation of Substrate blockchain, but with special focus on smart contract developments. For better development experience, we removed consensus. The reason was when we were developing contracts using Canvas, we found automatically generated blocks really bother us. Therefore, Europa only produced blocks when it received no extrinsics, no Wasm runtime. Although Wasm runtime is great since it allows now half-work blockchain upgrades, it really brings more difficulty to debug smart contract execution. It also has a state KV database. This additional database tracks all state changes when a new block gets mined. This is really helpful. When we are debugging smart contracts, we can figure out what the contract really changes underneath the hood. And another thing is the modification to contract palettes. It will reveal more details. Basically makes right now it's a black box. It will reveal the black box of contract execution. So a great thing with Europa, it also comes a graphic interface called Europa UI. We believe running a testing node should be as easy as possible and no setup should be involved. This will make Wasm smart contract developments more attractive to developers from all industries. And the UI is designed specifically for contract developments. You can download the binary release and start your block with just one click. It is built using the Electron and is available on all platforms, including Windows, Mac, and Ubuntu. But the thing is, you have to check your operating system version before actually using it because it has some requirements. So this is the sample pages we got from the Europa UI. We will show this later. The contract pages, basically, you can check all the state changes, making RPC calls with trees to get more insights of what's happening with the contract execution. It also has a nested view. So when you have a contract that calls another contract, it shows a very clear hierarchy of how it happens. Although it might be very confusing without Europa, but Europa really helps you writing complex smart contracts. So except from Europa UI, we also have Europa CLI. It means no more black box for contract execution. It provides custom RPCs and commands, such as like Europa forward to height. It basically forward the blockchain to a designated height, and Europa backward to height, revert the blockchain to a designated height, and removes all blockchain states after that height. Europa modifies state KVs. This is the database I just mentioned. It stores all the blockchain state changes. So you can use this RPC to get all the state changes. The custom commands is state KV, it is sent as the RPC, and the workspaces allows developers to switch to different workspaces for different testing scenarios. Another great feature is with Europa, it has detailed logging for contract execution. It will trace and print all the parameters and blockchain state changes during the contract execution. It provides Wasm Smart Backtrace to help you exactly locate where your bug is in a smart contract. Okay, so basically, this is the slides for today. The next step will be going to the demonstration. Where we illustrate how our tools can really facilitate developments. So this has so first we'll use Redspot to quickly set up a project using the templates. Then we are showcasing writing a ERC20 postable smart contract with access control. Then we will deploy it to Europa UI and show how Europa UI is so powerful that really helps you deploy your debugging and testing your contracts. And then the last step will be test the smart contract using Europe with the customized test script we write using Redspot. Okay, so for the people who are viewing this conference, so if you have access to like GitHub right now, you can go to our GitHub repository. I have posted them in the Discord server, and I believe the hosts, they have posted them in Hopping. So to stay updated and get a sense of how developments with a smart contract you should get up to GitHub and start doing the same thing I'm doing right now. Okay, so this is our page, our repository for tonight's demo. If you haven't actually clicked on it, please go to this page, and it has the README file and all the resources for tonight's talk. You can stay updated, follow me, get hands dirty with the smart contract development with our tools. So first, if you are on the GitHub, you should we have a demo setup. So first, start your RESTful projects using a RESTful templates. You can simply do that using the command here. Redspot new ERC20. Meanwhile, while it's fetching the node modules, let's also go to download the Europa UI that we'll be using to deployment and testing. So we have 3 versions here. Click on the versions that you will need. We have Windows, Mac OS, Ubuntu. Okay. So click on the version you will be using. So I'll be using Ubuntu for my environment. You can click on it. And if you are on Ubuntu, making sure you give it permission. It has the command here. You can follow this command, and then once you have this downloaded and you give it permission, you should be able to fire up your UI. So I already have this filed up. I will close it and start it again. It's taking some time cloning the templates because I'm more using VPN. It's probably why it's slow. So this is the Europa UI you will be using tonight. Yeah, it has some compatibility issues with Polkadot.js because Polkadot.js is really upgrading very fast right now. So it takes, okay. So so now this thing has been this directory has been instantiated by by Redspot. Let's go to this page. Let's go to this project. So as you can see, it already contains all the files that I'll be using. Contracts basically contains the contract examples. Redspot.config.ts basically stores all the configurations. So that's actually open this file in I'm using. Okay. Okay, so contracts basically the contract files. The script is the deployment script that will deploy your contract to Europa UI. and test contains this is the default test for testing just simple functions and methods in ERC20. And respot.config.ts. This file contains all the plugins, network settings that we'll be using for Redspot. So remember, this one is now pointing to 9944 as a port. So now if you have downloaded Europa, and please making sure, because Europa were basically taking 9944 as a port, making sure this port is not occupied by other applications. So for the database path, you can just choose whatever you want. The workspaces I'm using will be default. It has more configurations that allows you to connect to other running nodes, just using this as a front end. And you can also add Redspot projects to it. So you can see like all the products in Patract, they are closely tied to each other. So let's just start this blockchain. All right, so now we have started the blockchain, but you can see we already have some code there because I was doing some tests myself. Let's hover over to Explorer. In this page, we have two buttons, back to block and go to block. If you use back to block, so let's first use that go to block. Okay, let's just type 10. So Europa will basically, go to block 10 with all those auto-filled blocks. And just if we want to remove all the states, because we don't want all the stuff to bother us with contract development, just go back to 0. That way, basically cleans out the whole database. We have a very clean blockchain to start with. Okay, so let's just first, this is a very simple code. It's just very simple ERC20 code. Just the same code you will see on any Ink tutorial. Basically defines all the functions for a very basic ERC20 standard. But remember, we need to change some things here in toml.file. Because so if you go to our readme.file, you will see you need to remember changing the dependencies in car.toml to pull the files from crypto.io. Otherwise, we'll have compatible issues with polkadot.js. As just mentioned earlier, polkadot.js is really updating fast. So making sure you're pulling this data, you're pulling the files from chris.io. So let's just change over this file, this dependence here. Okay, so that's just first. So once we have all the things here, let me show you how to use Redspot just for deployment. If you go to the readme.file here, so once you have all the things listed above down, you just you can run this code, this command here, rpx npx redspot run. Sorry, I'm missing an n here. Just as you know, npx redspot run script.deploy.ts. This command will basically compile the contracts, then deploy them to the blockchain node I config in my config file. Yeah, making sure I add a n here. Yeah. Okay. So this will basically compile the code, upload the contract code, also the metadata to Europa UI. Just waiting for it to get compiled. Yeah, I'm sorry for Windows speakers, for Windows auditors. My demo is based on Ubuntu. I haven't actually used it in Windows. So if anyone is using Windows, please share like your thoughts and how it goes. Yes, I'm using it on my virtual machine. It's very slow, so bear with me for a while. I'm just while I'm taking a rest and drinking some water. Yeah, so the next thing we'll be covering is basically we will integrate Metis into our project. So with Metis, you have got an error on Ubuntu 20.4. I don't know. Okay, so this thing has been compiled, and you see it's being deployed to Europa with this contract address. Okay, let's go to Europa.ui. All right, you can see we have now another block called block 1. So this is basically means our contract, the simplest ERC20 contract is now uploaded successfully into the Explorer, into the Europa UI. Let's check it out. Oh, I'm sorry. So you might have the problems with like sometimes the metadata isn't uploaded correctly, but it's fine. You can just use you know, the button here to upload the metadata. It's basically in artifacts. You can see it's in artifacts. It's called ERC20 templates.json. It contains the metadata. which defines the methods you will be using. Okay. All right. So you can hover to instance cargo.lock. Name to build with. Okay. So let's look at this one here. All right. So if you look at this one, you see 5H. You know, this is the contract address. It's showing here. Now we are looking at this contract in Europa.ui. It has all the functions that we defined in the smart contract. If you call read, it basically tells you the you know, the stuff there. If you do call with trace, you know, with call with trace, it basically tells you what happens of the blockchain. That, you know, in the state side. It really tells you what the blockchain has changed in its databases. This might seem, you know, hard to understand, but if you are familiar with Patract contracts, you basically understand what's going on here. All right, so you know, if you hover to extrinsics, it tells you what happens here, and if you look at details, it tells you all the state changes of the blockchain. This is done by our state KV database. That comes with your UI. All right. So this is very simple. This is just very simple ERC20, but this is not enough. Let me just remove this thing as it's not very important. That is too easy for us. We are going deep with Metis. All right, so let's modify this project a little bit by introducing Metis. First, let's copy the dependencies in this file. Seems slow with my internet. Okay, but I have this locally at a border to workspace. All right, so first let's copy the cargo.toml file into the cargo.toml here. So if you look at the differences, it's basically we are introducing Metis in the dependencies. That's basically the only differences. And please notice Metis len is always required for every project. And all other dependencies are you just import them when you need to combine them together. So because I'm creating a ERC20 postable, I need the ERC20 component, honorable component, and postable component. You might be asking why we need the honorable, because if there's no owner of the contract, anyone can post this contract. That doesn't make any sense. All right, so after this, let's copy the still not loading. Okay. Let's copy the code in lib.rs. All right, this time is fast. I was trying to. Oh, no. All right, never mind. Let me just use the file I have locally available. Okay, copy this from. If you are on this page, just am I lagging because I'm not seeing anything? Okay. All right, never mind. Let's just copy the code from, if you are on Redmi, please copy this code here to, okay, I'm not logging. Okay, cool. If you are on Redmi, please copy the lib.rs from here into this directory we just created, right? Copy this to lib.rs here. So before, let's say something. Before we actually copy this file, let's open this file as well, right? Let's see the differences before Metis and without Metis. So on the left side is the one we have Metis included. The right side is the one without Metis. Let's see the differences. First, the use is quite different. In the native ink, we only have ink len as the dependency, while here we're using a lot of things. And let's look at the storage declaration here. With Metis, you no longer need to declare every variable yourself, right? So like ERC20 possible, it basically contains all the storage parameters you need for ERC20 possible and honorable. But we just list them here. You use ERC20 data, ERC possible, honorable. This is very easy, right? You don't have to memorize all the required, columns or like required variables you need. Unfortunately, the event stays pretty much the same because just due to the current design of ink. However, we will improve that later. So basically, with the next version of Metis, all the events here, it will be automatically generated by the macros. So as long as you declare them in the storage, those will be all generated automatically. So if you create a ER20 possible, just declare here, you can ignore all the events later, right? But that's in the next version. Okay, so you need to basically, put all the events here. This is for possible, honorable, and ERC20. The initiation makes a lot easier as well. It may seem big because actually we are initiate three storages for ERC20, honor, and possible. So basically just create an instance here. You put that into instance using ERC20.implement.init. Then you call the three inits here, then you just return the instance. So for the messages, which we call the functions, right? You no longer need to implement them yourself. Like if you have name, right? You just call ERC20 implement name. Basically, we have the implement for you. The decimals, those are the very standard things. So you still have to writing those things up. That's just the design. That's just Rust, because Rust doesn't have inheritance, so you still have to write them up. But it has advantages because now you basically all the functions you define here, you will see them in the blockchain. So you won't be messing up with hidden functions from a contract you inherited from. The transfer, this gets much easier. For transfers, you're no longer going to call those functions yourself. approve the same, transfer from, which is a very big thing in ERC20. When I was taking the the ink tutorial, it really gives me some hard time. And this is basically the same. Okay. So let's copy it over. To the file here. All right, save this file. And if you follow on README, you can now build a file, build the contracts. But making sure you're using this command here, because this will include all the debug symbols and not optimize the and build this in debug mode. So we can see more stuff during the contract execution. So cd to contracts, and then run this command. So while we're talking, let's so remember this is ERC20 possible, but it seems like we didn't actually in transfer here. It seems like we're not posting this transfer. Like this transfer is supposed to be posted if the contract's post. So what's going on? So basically, what happens is in Metis, we have extensions, which is very similar to extensions in Open Zeppelin. So we also have hooks. So basic extensions define hooks, and that with hooks, you don't have to put post, ensure post in every function we are having here. So if you go to the let me see somewhere. All right, let's have this file. So you can see this under ERC20 SRC extension postable. So with this function, you will be able. This defines the hook. Where further defines before token transfer, where in this hook, it basically ensure not post. So if the contract is post, it basically won't be able to transfer, right? And this hook is called within transfer from function. So every time when you do a transfer or anything like relates to transfer, like a transfer from anything, this hook gets called. That makes sure like if your contract is post, it's post. And you won't have to repeat writing all those logics here, right? Okay. All right. So you see all the is already compiled. This time is much faster. And if you are following on the README, please follow this thing. Just run these commands here. The reason was when Redspot was built, the cargo contract has changed a lot. So that makes the whole thing complete differently. So this one, because we built with debug mode, it has more information. Okay, so this one, where is this? Okay, so let's see the artifacts. All right, so okay, as you can see, we have all the files here. Let's remove the redundant ones. This is from the last one, we no longer need them. Let's remove this as well. All right, we have a clean directory right now. So let's use Redspot to deploy them using the deploy.js. We also need to copy the code from deploy.js. Let's do it here. In script, deploy.js, just overriding them with a new one. All right, so cd to the home directory, do deploy. Oh, sorry, making sure you add no compile. Otherwise, you are compile again because the default workflow was just running this command once, right, without compile self. Okay, great. So you can see this one has been deployed. Let's go to the Europa, our powerful blockchain explorer. Let's look at contracts. It still doesn't upload metadata. Never mind. Sometimes it happens. We're still trying to figure out why. Making sure you upload this JSON file. It contains all the metadata. And look at instance. All right. Now you can see all the functions are here. It has name, symbols, and all those special functions. You can check. You can check the state of the contract, and you can look at extrinsics. Okay, so this is all very standard. All right, so the next step is testing. Testing is very important for contract, especially integration testing. Means you're testing your contracts with the blockchain comes with it. So in README, if you're on README, just copy all the test files into the tests here, right? So I'm gonna just remove this one, move to trash, and then have all those test files, all those three ones, making sure you copy all of them into your test directory. Copy. All right. So we have three tests here, right? The first one is basic test if the contract has been initialized correctly. So this test contains the setup. We set up the whole contract using test. So every time we test, we have a new instance of the smart contract. So that won't get confused with the previous ones. Then this one just basic test. Oh, if it's called Metis test token, the symbol is met, all those things are correct. Let's just run the test. So if you're on README, just please follow this this command here. This one, this should just compile, test all the functions, right? I just mentioned, testing all the default things if they have. Okay, so all tests has been passed correctly. This was not very important. To see, you can basically check. Okay, this is this one, right? Let's check extrinsics. Okay, contract instantiated with code. This means this one has been tested correctly. Because this one doesn't contain any mutable functions, means that will be done by transactions. That only has one extrinsic instantiation. Okay, so let's hover to the next test. So the next test is a little bit different than the first one. It basically tests the ownable function to see, okay, if the owner is set up correctly. So the setup is basically the same. Basically initialize the contract, give some balance. do some basic transfers. Okay, so here's the test. So first we test, okay, if the initialization is okay, but it has to be initialized with the sender's address. And then the next one basic test, if I'm not the owner of the contract, right? Can I renounce the owner? Like suppose I'm not owner, I'm some guy, some random guy. Maybe I can hack this contract and just renounce the owner. So this one should definitely fail. And then this one means that the owner should be able to renounce its ownership. This one should be success. And then owner transfer ownership. The first one is we still do the same thing, making sure this one has been set up correctly. The owner is set to the sender. And if you are not the owner of this contract, you shouldn't be able to transfer ownership. Like the same scenario, I'm a random guy from a blockchain. I'm trying to transfer ownership of this blockchain to myself. Then I mint or transfer some tokens or mint some tokens. This one should definitely fail as well. And if I'm the owner, then that means I should definitely be able to transfer ownership. So as you can see, once you have read the artifacts, that's the one we just uploaded, ERC20 postable.json. You basically get access to all the functions you defined in the contract file. Okay, let's run this. Okay, so before this, because we really want to have a very clean blockchain. We don't want the previous test to bother us. Let's just go back to block 0 and then run the test. All right, true are passing. Let's see what happens in the blockchain. Still, we go to contracts. You can see we have this one here. This one is the one we just tested. Because we have two setups, that means we will have two instances. The one at block 2 is the first one, right? So let's look at this and let's go to extrinsics. Okay, so the first one is extension with code. This means the instantiation, and this one is failed. So what happens? Because I'm trying to renounce the ownership, even I'm not the owner of the I'm not the owner of the contract. If you click on more details, okay, here you see the Wasm arrow. So what's happening with this? This is the Wasm backtrace. That's a great feature of Europe UI. Basically trace back all the way, all the stacks, and trying to locate the arrow in your contract. If you look at this one here, you see, oh, this is the reason. It's honorable, implied caller is the owner. So that arrows out because I'm not the owner. I'm not supposed to renounce my ownership. This one, success. If I'm the owner, I should be able to renounce my ownership, making total sense. And look at this one. This one has been deployed at block 7. That's the later one. Look at extrinsics, the same. This one failed because I'm not the owner. How dare I transfer the ownership, right? And this one's a success because I'm the owner. I can transfer my ownership to someone else. Okay. So let's look at the third test. The third test trying to test the postable feature. Because it's called ERC20 postable, of course, we should be able to post this contract. And So the setup looks the same, nothing different. First, let's check. We need to check if the state is post. We just check that in using the blockchain explorer, right? Using the Europa UI, we click on get post state, right? It gives us post, and then non-owner should not be able to, right? Should not be able to post. If I'm not owner, I shouldn't be able to post the contract. And if I'm the owner, I should be able to post the contract. And if I'm the owner, I can also unpost the smart contract. This is very important because when your contract gets hacked or the blockchain is having issues, you should post your contract. Otherwise, you may have economic losses. So if you are transfer without post, it should all success. But when the state of the contract post, all your transfer should fail. So this basically, if you look in details, basically checks, okay, if it's unpost, basically your supply is minus by 1,000 and all those things. And when it's post, the balance should be 0 because it doesn't get transferred, and the total supply is the same. So let's run this test. Let's copy this one here. So this the whole thing should be very easy to follow. It gives you a sense of how the whole thing happens. And I'm very new to Substrate. I'm very new to Rust, but I can finish writing some smart contracts easily with all those tools and test them myself. So I think should be very helpful to everyone here. If you are trying to get into the smart contract industry with Substrate, all those tools should be very helpful. Let's run this last test. All right, so 3 of them are passing and tells you, the gas consumed. So let's go back to the blockchain and go to contracts instance. So the first 2 are done by the last test. So the last 3 one are here. You look at the extrinsics, success. It's just very standardized things. So all those things are success. And hover to the details to see what happens, what happens in the database side, how the blockchain changes beneath the runtime, right? All right, so that's basically today's presentation. I hope everyone has followed, and if you haven't followed or didn't get a chance to follow, please go to the link here. And if you don't have the OS that is compatible, just you can also use Europa CLI. It's very similar to Europa UI, but you just need to understand. You need to basically get sense of how to sending RPC calls, to sending commands and reading the logs. But the whole experience should be very familiar and similar to Europa UI. And anyone can build this build this locally, and so no matter what operating system you are on, you should have no problems. And so we will be publishing more tools and services and keep upgrading those services we have. So in future, basically, as I mentioned, the Metis will have everything generated. You just need to write the functions you want to expose to the public. and Europe UI will still be compatible with Substrate. We will keep it updated whenever Substrate release a new version. And Redspot, we will also stay updated with Polkadot.js and adding more plugins to make the whole experience more fluent or easy for anyone to get into. Thank you. This is my today's presentation.
Bonan, thank you so much. Super great workshop. Man, you really pulled it off. Like, doing a 1.5 hour workshop is not easy, and especially when you're alone. And so congratulations, man. Like, that was really cool. And
Thank
man,
you.
like, all these tools are super useful, and you're showing how easy it is to kind of just get going with them, right?
Yeah,
Also,
exactly.
thanks so much for putting. Yeah, sorry, go ahead.
Yeah. Especially like I joined Patract not a very long time ago. I was afraid, oh, I won't be able to do any smart contract developments. But when I get used to those tools, I'm finding, okay, I can write some very complex smart contracts just by putting them together. And I believe anyone else should be as easy as me to follow those things and create your own smart contract and, start contributing your value to Substrate.
Yeah, no, definitely. And I was also adding in the chat saying like, it's obvious that you guys are really focusing on developer experience, and I think that is really cool. Like how to just make it just easy for a developer who maybe is coming from Ethereum, for instance, where there are already all these tools that exist, and developers that are used to using these tools. How does their experience get translated to building with Substrate? So it's super cool. We do have some questions, Bonan. I'm sure you'd be eager to take a couple. So I will just dive right in. Does that sound good?
Yeah.
Sweet. So the first question is, so this is a question from Akim, who is asking that, okay, so the question is, you're mentioning Carpo, a smart contract cloud IDE on your website. Is this under active development?
Yeah, this is under development. We are trying to make this similar to Remix, where you don't have to set up anything locally. You can just go there and write your contracts, deploy them, just everything in one place. So that will give the perfect experience to developers.
Cool, super cool. Yeah, that's directly in line with your mandate, I guess, right? Making it very easy for people to develop smart contracts.
So that will have liberate you from setting up your local environment, because everyone has different environments. As I mentioned, Europa is based. We have your UI has 3 versions, but if you don't have compatible OS, you might have problems. But with Cargo, we will have everything in one place, and you don't have to worry about anything. And we will also allow you to deploy to our live network, so allow other users to actually interact with it.
Cool. So this is a beginner stage, and I think actually I do want to mention there was a lot of people following the workshop in the chat, which is really cool, and shows that this is like a great workshop to follow for people that aren't necessarily well versed in these tools and technologies. So one question to come up which was for beginners coming from the Ethereum space, what would be the first step that you would recommend that they take to jump into Substrate-based chains and smart contracts on them?
I think the first thing is just write your contracts and then play with it in the blockchain. You find it's very easy to actually get into. Write the project. If you have done some projects with Ethereum, just write the same ones using Ink and our Redis product. And in that way, you understand how the smart contract works, and you understand how Ink is different than Solidity. That will gives you the best understanding of how you can write up your smart contract.
Cool. Yeah. Like one last question. It's coming from someone who's obviously working with your tools maybe already. And the question is there any plan to work on upgradable contracts similar to Open Zeppelin?
Not yet, but we definitely we're like actually including the next version. Thanks for that. Yeah, that's a
Cool.
that's a very good start. We'll definitely include that in next release.
Awesome, Bonan. Thank you so much for taking the time today. It really was a pleasure to have you on stage.